Hi, in today's video I'm going to be covering an update to my ffmpeg scene detection scripts that will automatically chop up a video into different scenes. What I've done is change the output format from having sequentially numbered clips, for example Big Buck Bunny 1, 2, 3, 4, to having the start and end times of the clips in the output file name, so that you can actually see where the clips have come from. If we have a look here, what we can see is this video has been chopped up into clips, and we can see the start time and the end time of each clip. So 0 to 1185, the next one starts at 1185, and so on. So you can actually see where the video has come from, where the clip has come from rather. What I'm going to do is take you through the process of doing this manually by running 3 scripts, and then I'll show you the simple idiot-proof way of using a Makefile to automate the whole process, so you just have to type one line. What I'm going to do is come through and I'm going to delete all of these, and go through the actual process of chopping this clip up. So what we've got here is Big Buck Bunny, which is a Blender video that's open source, so there's no copyright issues. You can see here we've got Big Buck Bunny, and we've got lots of different scenes. And what we're going to do, chop this video up into clips. So what I'm going to do is come across into that directory, and let me just increase the text size here. So we've got Big Buck Bunny. So the way we do this is we've got 3 scripts. We have scene detect that detects the changes. We then have scene time that formats the time into something ffmpeg can use. And then we have scene cut that goes through the video and actually cuts it up. So what we do is we run scene detect -h to give us the help. We can optionally set start and end times where we want to process the clip. So if we just wanted to chop the video up into scenes from say 10 minutes to 20 minutes, we can do that. But what we're going to do in this case, we're going to do the whole video. So we run scene detect -I Big Buck Bunny and press return. What this is going to do, it's going to go through the video here, and it's going to analyze it, and it's going to output a text file here, Big Buck Bunny detection and the date and time. So if I open this here, what you'll see is a list of timestamps, and these are all the changes in the scene. So the first scene 0, the second scene 1185, and so on. What we need to do next is actually format this into something ffmpeg can understand, because ffmpeg works with a start time and a duration. So what we have to do is we actually, to get the duration, we have to subtract the start time, the end time from the start time, or the other way around, to give us the duration. So what we have next is scene time -h. We just give it an input and output. So the input is this detection file, and the output is the cut list that we're going to use with the next script. So scene time input Big Buck Bunny detection out, and we'll call this cut list .text. Okay, and what you'll see here now is what we have is a CSV file format with the start time and then the duration of each clip. So you can see here this first clip starts at 0 and lasts till 11.875. The next clip starts at 11.875 and lasts for 3.875 seconds, and then the next one. So you get the gist. So that's how we convert the time into something ffmpeg can use. We then run scene cut -h. We give it the input, which is the video file, and -c, the cut file that we just created. We run scene cut Big Buck Bunny .mkv c cut list, press return, and this is going to go through and cut the video up and automatically add the start and end times of each of the clips. So this is the long method, okay, doing it manually, but I wanted to show you this to give you an understanding of how it all works. And I'm going to show you the idiot proof method using a Makefile that even your grandmother could use. So this is going to take a few seconds to go through and process. This is like about a is it 12 or 15-minute video? So what we're doing is we're actually re-encoding this video as H.264 AAC, and you have to re-encode the video to trim accurately to the millisecond. So this should be done in a minute or two, and then once it's done, I will show you the version with the Makefile that automates the entire process. There's some tea. We can see the timestamps going past here. And I think it's got another couple of minutes, not in real time, but is in a couple of minutes of the video to process. We can see it's just reached 10. I think it maybe 12 or 15 from memory. I can't remember exactly. But once this is done, what we'll have is a series of clips with the start time and the end time of each clip. And what I'll go through and do after showing you the Makefile is actually show you the script and how this works, because what we have to do is some calculations. We have to convert from sexagesimal time, which is hours, minutes, seconds and milliseconds, to seconds and milliseconds. We then perform some addition to add the start time and duration, which then gives us the end time, and we can then add that to the output file name. So as you can see, this is also a good opportunity to see how long it actually takes to process a video and chop it up into different sections. Should be done in a second or two. Okay, there we go, perfect timing. So as you can see, what we've got here now is all the time codes. So we can see it starts at 0, 1185, 1185 to 1575. So you can see these all match. So the end time here is going to be the start time of the next clip. Makes sense? So you can see here, this is the intro. See, that's the length of the video. Oop. So the other advantage of this is you can actually go through and easily see where this these clips have come from. So you can see this one's going to be a 2-second clip here, like that. I love that bit. Okay, so you get the gist. So you can see how this all works, and the manual way of running this with 3 scripts. So what I'm going to do is just delete all of these and redo it with the Makefile. Okay, so what we've got here is just the Big Buck Bunny script, video rather, and what I'm going to do is copy the Makefile into this directory. So the Makefile is also in the Git repository for the scripts. So what we have here, coming to the Makefile, is some basic instructions about how you use this. So what we have here is a default input file name of input.mp4 that you can override on the command line. So instead of running those 3 scripts manually, all you have to do is type make input equals, you can press tab, and then big buck bunny, so we've got B here, press tab, and it's going to auto complete. That's it. That's all you've got to do. Make input equals, and then the file name, press return, and it's going to go through and do exactly the same thing. So you can see here it's starting to create the clips now. So while that's doing that, what I'm going to do is actually come across to the script and show you the changes. So the changes that I've made are this section here, this block of code, end time, print, start, duration, and then we run it through awk and do some calculations. And then we have this output equals input name dash start dash end time. So what that does is that takes the input name, which is the file that you're actually processing, and it constructs a out file name with the start time and the end time of each clip. So that's the actual code here. We're running it through awk. We're splitting the time codes that are separated by colons. So hexadecimal time is hours, minutes, seconds, milliseconds, separated by colons, except the last bit, which is a dot. We split it, we do some multiplication, and then add it all back to we have to convert it from hexadecimal time to seconds and milliseconds. We then do the calculation and then convert it back into hexadecimal time to give us the end time of the clip. So that's the scene cut script, and I've removed a bit of code here that was actually used to create a counter that would increment. So in the previous version of the script, what I was actually doing is creating file names that would be big buck bunny -1 -2 -3 -4, which worked, but the issue was you couldn't actually see where what point the video came from, what point the clip came from in the video, whether it's 5 minutes, 10 minutes, or whatever. And you couldn't see where the clip ended either. So what I've done is pinched this bit of code that I use in another script called trim clip. So bin trim clip. So exact same bit of code as I was using in the trim clip script, which is used to trim a audio or video file on the command line to the millisecond, and that also adds the start time and the end time of the clip to the file name. So what I wanted to do was actually have the same output format with the scene detection script. What I've also done is scene images. Okay, scene images. So all this is chundering away in the background. What I also have is a script called scene images, which works with the detection file that we used to create a list of all the scene changes. And what this scene images script does is it will go through that text file with a list of all the time codes of the scene changes and extract a frame from the video at that point. And it will also add the time code into the output file name. So, for example, the first one will be 000. The next one in this case would be 11.875, and so on. So what it will do is actually give you images from each of the scene changes, basically. So you've got a sort of visual representation of it. And I'll show you that in a minute, but let's just see if this done. Yeah, so that's done. And what you can see here is we've got exactly the same output the input file name dash start time and dash the end time. So you can see here, these all line up. So this is all bang on accurate to the millisecond. You can see here 11875. The next one is 11875. End time is 1575. 23042, 23042. So you can just come through, and it also lets you see the length of the clip. So I can see automatically this is a 5-second clip here. So you can see that's all worked. So what I'm going to do now is remove all those and show you the scene images script. So rm big black bunny dash yeah, MP4, my bad. Okay, so what we've got here is I can get rid of the cut list. So when we ran scene detect the first time manually, what it did is it would create this detection.txt file with the time codes of all the scene changes. So what we can do is we can run scene images -h for the help, give it the input and the cut file. So scene images input big buck bunny -c and the detection file. And what this is going to do is go through that text file and seek to all those points in the video and extract a frame from the video. You can see here it's just going through. And give it a second. So what we have here now is a load of PNG images, and you can see the first one is black, obviously, because it fades up from black. You can see the time codes all correspond, 11875. So this is a way that you can automatically create an image from each scene change. Okay, and you can see all these time codes are going to correspond to what's in this text file down the bottom. So just come scrolling down, you can see the last text, last input is 956416. 416, yeah. It's not got the last one because I think that is a black frame or something, or the end of the video. But for this case, for what I'm doing here, just wanted to knock up a quick thing showing all the images from the start of the scene. It's really really useful, and you can see these all 1280 720, and that's because that's the size of the video. Okay. So that's the new output format. And as I said, dead easy to use. All you have to do, you can do it manually if you want to, but there's not really any need. All you've got to do, is put that Makefile in the same directory as the video, and then all we did was we ran make input equals and then the name of the file. And these scripts will work on Linux, Mac, Unix, and Windows as well. You can either use the Windows subsystem for Linux, or you can use Segwin to use the script. However, if you're using Segwin, I haven't been able to get the Makefile to work, and so you will have to run the scripts manually one after the other if you're using Segwin on Windows. If you're using WSL, the Makefile should work, and you'll just be able to do scene detection as I've shown you here by putting in the Makefile and running this command here to actually chop up the video with all the time codes in the output file name. So that's all for now. I'll put links to all this under the video, and hopefully that's a better output format for the scene detection output file names, so that you can actually see where the videos come from, what point the clips come from in the video, as opposed to having just 1, 2, 3, 4, 5, 6, 7, so on, which doesn't really tell you much. It will show you how many, you can have 40 clips, but you wouldn't know where they actually came from in the video. So having this output format's much better. And as I said, what I've done is my bin directory. So the trim script, so the scene detect and scene images have this output format, as well as the trim clip script and the extract frame script. So where's the extract frame? Extract frame. I think this has got the same format, has it? I thought I'd put the output file name in this as well. Let me just check. Yeah, seconds. Yeah. So let me just remove all those PNGs. Section, Makefile. So extract frame -H. Extract a frame from a video as a PNG file, and basically all you do is you give it the input file and then the start time where you want to extract the frame from, and optionally an output file name. So you can use the -O option and give it an output file name, but by default what it's going to do is create an output file name with the input file name and then the time code in hexadecimal format from where the clip came from. So so let's just grab a so say we want to grab this frame here. I'm getting an error here. So we want to extract the frame from 124/250. Grab that. Extract frame, input Big Buck Bunny, start that. There we go. So you can see here the frame has been extracted at that time point, and it's got the time code in the output file name, so you can see exactly where that came from. So let me just come to the desktop. So you can see that's the exact frame that we wanted to pull out, and you can see we've got the hours, minutes, seconds and milliseconds in the file name, so that we can easily see where that clip has come from. So all you've got to do to update is run a git pull. So here's the ffmpeg scripts. Here's the German version. So this has been updated as well. So this is all in German. So exact same scripts, exact same code, just the output is in German. So here's all these scripts. Here's the instructions to install them if you haven't installed them before. But if you have, all you need to do is a git pull, and it will pull down the latest version with the new additions to the output file names to make it easier to actually see where those video clips or images came from. So hopefully that makes scene detection a bit easier. So as I said, piece of piss to use. Install everything, drop the Makefile in there, make input equals the file name, and it's going to do everything for you, automate the whole process, and give you a nice output listing with the start and end times of each clip in the file names to make it easy to see where they came from. So that's all for now, and I'll stick links to this under the video.